Hi, my name is Charles, and I love mangoes, and I also love boba. So for this experiment, we're going to combine those two to create mango popping boba.
After a bit of research, we find out that the process is through reverse purification, which sounds fancy, but it's basically trapping juice inside a jelly membrane. So that allows us to make mango balls that pop in your mouth. Okay, let's go to lab.
Okay, now that we're in lab, I can be a little nerdy. So the basic idea is that when you drop a calcium lactate solution into a sodium alginate bath, small spheres form as the liquid hits the surface. What's happening is that the sodium alginate, which is a type of polymer, reacts to the calcium ions from the calcium lactate. These ions trigger cross-linking between the alginate chains, forming a thin gel membrane around the outside. The inside stays liquid, so you're essentially encapsulating whatever you drop in: juice, flavoring, anything you want. My hypothesis was that the lower pH would produce larger beads due to increased protonation of alginate, allowing more efficient cross-linking. Higher pH would lead to smaller beads because the gelation will be less effective. I started with 150 ml of mango smoothie and added 2.5 grams of calcium lactate. Then I split the solution equally into 3 beakers, 50 ml each. Beaker 1 was already pH 4, so no adjustment was needed. I raised Beaker 2's pH to 7 and Beaker 3 to pH 10 using potassium hydroxide, checking each with a calibrated pH strip. After formation, each bead was transferred into DI water for a rinse and then into a calcium lactate brine to settle for 30 minutes.
Right here. Place that's right next to sushi.
pH 4, pH 7, pH
1100 calories.
10.
Alright, it is time to measure my balls. The results showed that the beads formed at pH 4 were the largest, while those at pH 10 were the smallest. This supports the hypothesis that lower pH levels enhance gel formation, resulting in larger beads. Research indicates that at lower pH levels, alginate molecules can form gels more effectively due to increased protonation, which facilitates cross-linking with calcium ions. This results in stronger and more extensive gel networks. This experiment demonstrates that pH significantly influences the gelation process in reverse purification. Understanding this relationship is crucial for applications in food science and other fields where precise control over gel properties is desired. Now you have it, guys, a step-by-step tutorial on how to make your own mango popping boba. What we learned is that you don't need to add potassium hydroxide, thank God. So if you ever want to make your own popping boba, all you need is mango, orange juice. I love some orange juice, but yes, you're welcome.